Now see some problems. The first problem is given so that every positive integer, even integer is of the form 2q, okay, and that every positive odd integer is of the form 2q plus 1, where q is some integer. Now firstly we can see here we have to show that every positive even integer is in the form of 2q and every odd positive integer in the form of 2q plus 1. So firstly it means because you can see this is 2q plus 1 and this is 2q plus 0 also, you can say, because this is 2q, so we can take this is as 2q plus 0 also, because it means here remainder is 0. So firstly we should take a, and the second integer we should take 2, because you can see this is very clearly mentioned here, this is in the form of 2q or 2q plus 1. So it means we have to take the first integer as a and the second integer as 2, and in this condition we can take a is a greater than 2. Clear? Now in this condition, if suppose that you are dividing this a by 2 and your quotient is q, so it means suppose that you are dividing this a by 2 and your quotient is q and remainder is r. So you are aware that according to Euclid division lemma, what you will get here a equal to 2q plus r, and here already I told you the relationship between r and b. You can see r can equal to 0 or greater than 0, but always less than b. So for r there how many possibilities are there? Here b is 2, on the place of b we have 2. It means r can equal to 0 or greater than 0 but less than 2. So how many possibilities are there? It means r is equal to 0. This is the first possibility. So firstly we have to check for r equal to 0. So suppose that this is our equation number 1 and here r equal to 0. So in this condition you will get a equal to 2q plus 0. Now you can see this is in the form of 2q, and this is a, how can you see this is a even number? Because this is the multiple of 2, because you are aware if we having this is in the form of 2m, where m is any integer, so it means this is a even number and this is in the form of 2q. Now see the second condition. Now because this r is equal to 0 or greater than 0 but less than 2, so the second condition is r equal to 1. Now you can see if r equal to 1, in this condition you will get a equal to 2q plus 1. So now in this condition you can see we can write this is 2 into m plus 1. Why? Because here suppose that if m is any integer, in this condition you can see 2m plus 1 will always a odd number. Why? Because see if m is any integer and you are multiplying by 2, so it means this number will be even number, and this is plus 1, it means you are adding here 1, and you are aware if we add even plus odd then always what you will get odd number. So it means this a equal to 2q plus 1 is a odd number and this is odd positive integer and this is in the form of 2q plus 1, because here in this question we have to show that every positive integer in the form of 2q and every positive odd integer in the form of 2q plus 1. So this is proved, and here we have to take only two cases, r equal to 0 and r equal to 1, because r is a less than 2, because r cannot be equal to 2, r is a less than